Hello, Web Audio Conference. I'm Peter, and I'm sorry for not being able to be in person with you, but still very happy to be able to give this talk. So thank you for having me. And I will talk about WebAssembly Music, which is a project I've been playing with a few years. It's inspired by executable music from the demo scene, where it's about having all the music inside tiny executable files, typically less than 30 kilobytes, and containing all the logic and for rendering the instruments, the sounds, and also the music itself. So I've translated this concept to WebAssembly so that everything runs in the browser. And I'm using web audio only for the audio output because everything is going on inside the WebAssembly binary. Everything that comes to effects, the synthesis of the sounds in real time, and the music. So I have a live coding environment here, and on the left side you can see that there is JavaScript for all the nodes and the MIDI data. So it's JavaScript generating that, and on the right side it's the code for the sound synthesis. So all effects and all the instruments are coded in here, and I can code live and have it compiled on the fly because this is a feature of AssemblyScript, which runs perfectly in the browser. So let's hear what it sounds like. So that's a song, and we can also just play the instruments here. So we have the pad, and we have the bass, for example, and some organ. So all of these instruments are defined in here, and I'll show you later how to code and update on the fly. But an interesting feature here is the possibility to be able to export to a WAV file. That's one thing, but also to a WebAssembly binary. So then you get that tiny WebAssembly binary that contains all the code and all the MIDI data that you have set up here. And you can use that for creating these executable files, either a native executable or an HTML file that can play this. So let's move on. This is my setup in the browser for this live coding environment. It's using AudioWorklet for low latency, for real-time performance, and this AudioWorklet processor contains the WebAssembly synth, which is doing all the work. And the web MIDI is connected too, so the MIDI messages are sent via the message port. And let me show you an example of this tiny WebAssembly binary inside an HTML page. So here is an HTML page. Let's just look at it. It's one single file that contains everything. So inside here you can see that the WebAssembly binary is contained in base64 format, and we are calling that WebAssembly binary from here. Just play events, MIDI events, fill the sample buffers, and we are creating buffer source nodes in this case, and just sending it to the web audio outputs. And then it sounds like this. So that's it. And to create a simple sequence, well, that's the JavaScript code, and you can see here we are creating a track, and we are setting up the MIDI nodes here in sequence. So we can just copy that into an empty environment that I have here. And we also need some synthesizer code, so let me just move on to that, which is here. So I'll copy now this here, and what you see here is a very simple instrument. It's just a sine function. We are translating the note frequency to the angle parameter into the sine function, and we are adding that sample onto the channel output, and that's it, more or less. So let's go in here and just paste it. And now we can also try it, and we have the sequencer enabled, so we can just start playing. And let me also alter the sequence while we are playing. So change some notes like that. So you can hear that, and let's also have more steps. So yeah, and we can also just play the instruments by turning off the sequencer. We can play it from the midi-keyboard. And let's also just demonstrate altering the instrument itself. So let's add another sine wave to it, just like this. So let's say 0.7. That will give another little higher frequency. So pretty easy to just experiment with different setup on the fly. Compiles on the fly. Let's move on. So the next is what I've been playing with now the recent year. It's physical modeling, very complex topic. I have still a lot to learn. I'm trying to catch up of a lot of things, math I should have learned in my 20s, but you know, it's never too late to learn stuff. I've read a lot on the notes of Julius O. Smith. He's the expert on this, and Pierre Cusa has some really nice, simple tutorial to get you started. And I think there is no better interface here than live coding synth for experimenting. The concept is just a burst of noise. Well, very simple said, but and you kind of make sure that noise has some envelope and filters to it, and then you put it into a feedback loop where the delay is delay buffer size is according to the note frequency, and you also filter that, so it goes into a loop here, and that starts to resonate, and then it generates a tone, and very kind of gives you the possibility to create quite interesting instruments. So let's hear it. Let's see it first, the code here. What's really going on here is inside this processing. So it's what I just showed you in the diagram, where you have the exciter signal, the noise, and you just feed that into the delay line here. You process it with a filter, and you kind of add it also to the existing signal. So and here up here you just set it up based on the incoming note frequency, the incoming velocity, and yeah, and let's just copy that and add it here to our synth code. And we also need to, now that we have this waveguide, this is not a full instrument, so we have to connect it to this first instrument that we set up. So just let us set it up, and the first parameter is the attack, and we need to have some decay and some filter for the feedback, and finally the feedback. So let's set it like that. And now we actually want the sample to be taken from the waveguide. So let's call the process method. Like that, and also let's here start the waveguide. So this waveguide and start, and the input is the note frequency of the note, and let's now just set a fixed filter value, not involve the velocity here, and well, that should really be it. We'll just see what compile errors we get. And now we are missing some imports, so let's add that on top here. Just add it to there's no complaints left. Like that. Filter type we need. And we need the filter coefficient for the biquads. Noise is very important for generating the signal. So let's try and play it and see. So, okay, we can hear that something is going on here. So then we can start also just playing a bit with the parameters. So let's have a look and change the filter, for example. So also this filter here on the feedback loop. So it starts to get a bit more interesting. So you can hear it kind of resembles a string sound now. Let's just remove the feedback, and then you can hear it's just a burst of noise. Like that. And also let's try with negative feedback, which is very interesting because then you get more flute characteristics here. So, okay, let me go in and show you some more advanced. Just move to the string instruments, and here I use my pre-setup in my AssemblyScript library that I've got here. It's all this waveguide code is ready, so you don't really have to set it up every time. So here I have two waveguides to create a nice stereo effect, and just by setting the parameters for it, we will get a more string sound. So I'll copy that into the environment here. Then we need a new channel for that instrument. Let me set up that. And let's also allow like 10 voices simultaneously. We miss an import, so let's add that since I'm not using that simple waveguide now. And also let's just add that string instrument so that it shows up here in the dropdown. And let me play. So. So now it's starting to sound more interesting. So, I have a lot of instruments here. So let's just check it out. For example, here is a piano. And we got the string already here, but the drums is also possible to create using this concept. So it's only the same concept with and bass is kind of cool. And flute is one of my favorites. And finally, let's check out the choir. So as you can hear, there are endless possibilities here, really. The piano is kind of the complex thing. It's very difficult. I haven't got it right yet. It's still struggling with it, but I'm trying a lot of things. I'm reading a lot and trying the best I can here. But some stuff it's to add here is the dispersion to get kind of a stiff string, or also the possibility to create a bit out of tune, which is important with the piano, and also the soundboard, which is kind of enhancing all this sound from the string that is mixed together. So this is actually simplified diagram of how it really is. Let's look into the code. We have also here for the exciter some delays because we want the strike to the string to happen multiple times in delay. And we also have, the dispersion I just mentioned. We have here a lot of cascaded all-pass filters, and finally also the piano channel, which is the soundboard. So all the piano notes go in here and are mixed and just added in multiple all-pass filters again. So let's copy that and let's just create yet another instrument. And what we need now is also an additional channel. So and this time we need to use the piano channel because we need that soundboard and the piano. And now we see that we missed some imports in the top again. So let's just add it from the library. The delay line also is important. So there we are. Let's try it. Let's choose. Oh, we also need to add the piano here. Like that. Piano. And let's just hear it. Select it too. We can also just add some reverb to it. So then I've actually implemented in this MIDI synth controller 91, which is the typical for a reverb. Let's just set it to like 50. And let's just also see what happens if we remove this all passes for the piano channel. Then it sounds like this. So just need to see. Okay, so yeah, quite annoying. so we need that. And also let's play a bit with the dispersion, which is quite interesting. So here it's 0.15. Let's turn it up to 0.3. So it becomes more out of tune, and that's also an interesting feature of some pianos. Yeah, so again, a lot of things to play with here. And finally, the full band. This is a song with a lot of instruments. Let's just hear how it sounds all together. So I'll skip a bit into the song. So that's all from me. So thank you for attending. Thanks for watching, and I hope you enjoyed it. So see you later. Bye.
So we'll now have time for some questions.
Yeah, but Peter will be online.
Yeah, Peter will just appear on the screen in a moment. Ah, hello Peter.
Il n'est pas allumé tout le temps.
Hello. Can you hear me? Well, we can't hear you. 1 second.
Okay. Yeah.
It works now. Perfect.
It works now. Okay. Bonjour tout le monde.
Bonjour, Peter. Does anybody in the audience have a question for Peter? Attila or Michel? Yeah.
Yeah, so I was just wondering how big, like the binaries you showed were really tiny, 30 kilobyte, I think. So I'm wondering if, like, how would you handle samples or any kind of assets files that you would ship with the song, usual tracker setting or usual, composition, if you're not only dealing with synthesis.
Yeah, so the question is, how do I handle samples if there are more than just synthesis? And most of the songs I've done until now is purely synthesized, so there haven't been any samples at all. So everything is possible to ship inside these 30 kilobyte binaries. But I've also created a function inside this live coding environment where you can add audio. You can actually add a WAV file and you reference it from a URL, and it will just load it into memory and send it through this WebAssembly binary. So you can use all these effects that you have in the WebAssembly binary yeah, you do whatever you want with it. So you can play it and you can mix it and you can enhance it. But and then in case of shipping the total music, of course you have to export it to a WAV file. It's probably too big for a single binary file, but yeah. So,
yeah, that answers it. Thank you. It's really cool.
Okay. So, anything else? One question.
Hi, Peter, it's Michel. So we already exchanged with Peter. I was wondering why he did that. So why did you reinvent web audio or whatever? And maybe you can explain your background from the demo scene, and that the fact that you wanted to export very tiny pieces of code that could be embedded in a video game or in any kind of application. Could you speak about your background and why you did that?
Yes, so about my background. I started in the demo scene on the Commodore Amiga in 88, I think, something like that. I started programming in 1985. And back then it was all about having to make demos. A demo is typically graphics and music and some content which should fit on a floppy disk. And the floppy disk at that time, they could room like, I think it was like 180 kilobytes, which is actually more than we use now for these WebAssembly binaries. But this has been going on in the demo scene all the time to be able to create these presentations and music demos as tiny as possible. And today you see them down to 4 kilobytes and quite still impressive. I've even seen things in 256 bytes, which is very impressive too. But I just wanted to take that concept also to the browser. And when WebAssembly came along, I saw that possibility that you could actually export music content. You could fit it into this single WebAssembly binary. Like they also do the demo scene today. If you go to these demo parties, you have these competitions about executable file less than 32 kilobytes, which should room music. And it sounds like real stuff, like impressive instruments and all this. So I just want to take that to the web browser. And that's also why I'm not using web audio for, well, I'm only using web audio for the audio outputs and not for actually assembling the sounds, because all that goes on into inside the WebAssembly binary. So
Yes, thanks, Peter. Thanks, Peter. And may I add something? Is that I tried the software and the sound of the instruments is much better than what we heard with the video. It doesn't doesn't reproduces faithfully the sound, and the instrument sounds really good. And yeah.
Anybody else?
Yeah, I think that's important to say that the video is kind of degraded. So to get that full experience, you really need to hear it from the web browser itself and play with it. And also even when shipping the music as WebAssembly binaries, you get a full quality compared to an MP3 file, which is not really the same. So that's also an aspect of it, that you can ship it with full quality.
Hi, thanks for the demo. It was really nice. I was just wondering, is that a private experiment, or do you intend to? Do you have a GitHub repo, or do you want to make this available and with contributors, or is that just an experiment?
It is available on GitHub. It is a GitHub repository. It's github.com/Peter/Salomonsen/JavaScript music, because it started as JavaScript music and involved the WebAssembly music. So you can explore it a bit there. Well, for me, it's been a private thing. I made it for creating music myself, but still, it's open for everyone to fork and even contribute if they want. I think for me, my main focus is to just create music with it and create demos and yeah. So, but you find everything there.
Okay, thanks.
Any other question? Okay, thank you very much.
Peter, we see the weather where you are located, and it's really a shame that you are not here. Here, it's sunny, it's hot, the sky is blue. So it's why are you located in Saint-Jean-de-Luz right now? I don't understand. Yeah, you made a big mistake. Trust me. Next time, listen to me. I just had, let me just add that Peter has a very well documented video blog, or I don't know, on his YouTube channel. He posts videos regularly about what he's doing and so on. And we talked together for a long time. So I don't know if he agrees to talk with any of you for hours, but he's somebody very passionate. Thanks a lot, Peter.